please. Good evening. My name is Lou Crampton. I'm the President and CEO of the South Florida Science Museum, and I want to welcome you to the first presentation in our newly launched Edgar Mitchell Science Lecture Series. We're glad you're here. This series is designed to take a look at the hard science of issues you always wondered about, but were afraid to ask. Tonight's talk by Harvard-Smithsonian astrophysicist Dr. Rudy Schild will be followed by three lectures on similar topics starting next season. So we hope you'll be back with us again next year. This lecture series is being generously underwritten by museum supporters Mike and Suzanne Ainsley and by Eric and Lucinda Stonestrom, but I don't see Eric and Lucinda here, but they will certainly be here shortly. We have a planning group that is working to plan other lectures of a similar cast. Edgar will be advising us, and Rudy will be popping in from time to time. If any of you in the audience are interested in joining our group and being a part of the planning process for more of these lectures, please let me know or let one of my staff know, and we'd be happy to include you in the process. There's Eric and Lucinda back there. Let's turn around and give them a hand around. The museum's goal with this series is to present cutting-edge work in the field of psychic research, a subject often ridiculed as unacceptable in respectable scientific circles. But psychic research, as it pertains to the understanding of consciousness and the relationship of body to mind, can no longer be ignored. There's a growing body of scientific work relating to the topic of consciousness and its role as the central unifying concept behind the rational, objective mind and the subjective knowing. Research over the last 50 years by several forward-looking thinkers has shown that there is a vast creative potential in the human side or human mind that is as yet almost totally unrecognized by science. Most scientists avoid metaphysical implications in their work. But modern science, which began with the work of Newton and Kepler and the Royal Society back in the mid-1600s, had its origins in just such an environment. At that time, science was rife with superstition and religion and mysticism. And the work that Newton and his colleagues performed in order to bring order and discipline to a world where life was, in the words of Edgar Hobbes, nasty, brutish, and short, proved to be a great leap forward for mankind. Now there are scientists, Dr. Schild among them, touching upon new areas of inquiry. If, as these scientists seem to say, we are in constant and instantaneous contact with our environment, and if all information in the cosmos flows through our pores at every moment, then our current notion of our current human potential is only a glimmer of what it could or should be. Much of this work has been carried out and championed by the man whose name graces this lecture series. Edgar Mitchell is a true American hero. He grew up in Roswell, New Mexico, and received his doctorate in astrophysics from MIT. He put in his time at Chuck Yeager's Flying Circus in the Mojave Desert, was a member of the crew of Apollo 14, and was the sixth man to walk upon the face of the moon. Edgar is a longtime friend and supporter of the Science Museum, and we are pleased to benefit from his help and inspiration as we explore how his journey took him from outer space to inner space. Ladies and gentlemen, please welcome Dr. Edgar Mitchell. does. Just pull it out.
Oh, okay, I can pull it out. Fine. Well, it's a pleasure for me to be here today to welcome you to this lecture series and to thank Lou from getting it going, helping us get it going.
There you go. This one works.
Pretty close. And to have my friend Rudy to be our first lecturer. And we're trying to I was reminiscing. Where did we first meet? Was it the CC conference in New Hampshire?
Yes, it was.
I thought it was, right. The CC conference is alternately in Italy or here in the States, and that was where we first met that. 7, 8, 9, something like that.
I think 11.
11. More time though. But that's what it is. And we've been friends, and unfortunately, we've lost one of our friends. He's gone back, a friend of both of us, in Harvard, and in the series. And come a long ways. I want to thank Suzanne and Michael Ainsley for helping make this possible today. And we'll go forward and have more lectures. I brought up here to show you one of our efforts that we've worked on. This is called the Human Mission to Mars, Colonizing the Red Planet. And there's 2 chapters in here, 2 papers in here, by Bob Sturridge and myself. Bob, you want to stand up and wave your hand to the crowd? Rudy is one of the editors of the Journal of Cosmology and one of the editors of this book. And we have another book that we all worked on together, Consciousness. And it's a book the same size as this one, so if you're really into heavy reading, Amazon these books and read forever. They're pretty thick. But it's a pleasure to present it to you and to be here to present Rudy Schild. And as you already know, he's been a lecturer at Harvard for quite a long time. His current lecture series he's a senior researcher at Harvard and the Smithsonian Center for Astrophysics, and with many papers and much work, and got his PhD from the University of Chicago quite a few years ago, and has been generally in the field of investigating young stars and star clusters, interstellar medium and dark matter, quasars and gravitational lensing, all those way out subjects that we're interested in. And a lot of these going to be talking about dark matter and dark energy today, and because that's kind of on the future as we have from space with NASA over the last 25 years, put newer and better telescopes into space, and be able to see further, see more, and it's totally changing our ideas about the size of the universe, what's in it, how big it is. And I oftentimes lecture to children in school quite frequently, and I point out we really think we're pretty smart, and our science has brought us a long way in the last 100 years or so. But by Mars, as far as it comes of knowing the universe and really knowing how it's put together, will show the very young truths. And we've got a long ways to go before we really have it under control. And fortunately, folks like Rudy and his team and the people he works with are helping alleviate that bit of ignorance, that large amount of ignorance that we still have about the way our universe is put together. So without further ado, let me introduce our guest for today, Dr. Rudy Schild. And
I think you can all hear me okay. My wife will tell me if I fall back on my dark, sexy voice, but I don't. And thank you again all for coming, and I thank Edgar Mitchell for being Edgar Mitchell. He's the person who I nominate for the Nobel Prize because in his formulation of the quantum hologram, I feel that he has really come to understand how the universe works to enable what I now call and bring to you as the modern miracle. Now, Edgar alluded to the fact that we have a problem. There are a great many successes in our science program today, and the American population has actually acceded to the academic imperialism of the science community, where scientists tell you what is important to do, and we will do the research, just send us your tax dollars. And there's a problem with that in that many people have experiences that go way beyond what scientists are talking about. So we want to talk about dark matter and star formation, but what about the things that science can't explain? I call them the modern miracles, and here's a listing of many of them, and I hope many of you relate to some of these. What about people describing past life experiences? There are actually people who say that statistically these can be shown to be correct and true, and people are having real identification with past lives. So why isn't science studying past life experiences? And what about near-death experiences? What about telepathy, UFO sightings, abductions, precognition, dark circles, remote viewing, astrology, or balls of light, ghosts, fairies, parapsychology? And I bet you that many of you have had other experiences of this kind. I will call them collectively the modern miracles. And it is my experience that our civilization, not only the science community, our civilization has adopted what I call a divide and conquer approach towards it. It's just those UFO nuts. It's just those parapsychology people and their random number tables. He sees ghosts, ha ha ha. Send it all off to the natural choir. Divide and conquer. None of it is seen as real, but the fact is, what we will talk about today explains all of it. It's entirely possible, and I believe true, that we live in a universe where these things that are happening to us as human beings have an understanding and an explanation, and that's what we're going to talk about today. Now, you're reading in the newspapers and Scientific American that we have some new weapons in science, we have now some new understanding about the universe, that we've come to terms now with the existence of a dark energy, and nobody can understand what that is. We're talking about two kinds of dark matter. I'm not even convinced myself that these exist. And what about the wormholes that we talk about? I believe that such structures exist in the universe because the existence of dark energy implies that wormholes should exist. I think that our picture of wormholes as a round tunnel is perhaps too simplistic, but on the right track. And we won't have time to talk too much more about that. But I want you to understand then that astronomy does have its own mysteries. The practice of astronomy at the professional level does talk about what are all of these things. Perhaps we don't have all of the answers, but that we only say to ourselves. Now, a very key player in all of this is black holes. And I have investigated black holes now for about 20 years because we have a new technique for studying them. We use a peculiar effect of the general theory of relativity called gravitational lensing, where, as you remember, a gravitating body can bend starlight. And this was first seen in the fact that if you look past the sun during eclipse, you can see that the star field behind the sun is distorted. That's how the general theory of of relativity in Einstein's day in 1919 was confirmed. An extreme behavior of this is the formation of two images of a distant quasar. I don't have time to talk about what a quasar is. They're very different light beacons in the sky halfway across the universe. By studying those things dominated by their black holes, we can come to understand something about the nature of black holes, and this I have done. And from this, we have formed the following picture of what a black hole is. And to help, I want to come to the screen a bit more. And can you all see this laser pointer showing the central object? Can you see that? Yes. Okay. So at this point, at the center is the black hole object. And what we see is that the overall structure is dominated by outflowing fields of matter. We can measure these astronomically. We also see that there is a dark ring of matter whose inner edge is light, but there's a darker ring outside that keeps bringing matter into the black hole. It's called, in technical literature, you maybe saw the word accretion disk. So in-spiraling matter comes around in this way and tries to fall into the black hole, moves faster and faster and faster until the magnetic field senses it and casts it back out in a fast movement. This structure is what we now know dominates a black hole object, but guess what? The standard black hole theory does not allow a magnetic field. The Hawking black hole cannot have a magnetic field. We have gone and found that there are alternative solutions of the Einstein-Maxwell field equations, and that these are what nature makes. Nature makes an object that's called a MECO, meaning magnetic, eternally collapsing object, and I will be speaking more of it, but first I want to show you pictures of other objects that are like it, because this picture that I'm showing you now is a picture made by an artist from the observations that I have made. When we looked to the sky, we found other objects that are like it. Starting with this one. This one has at its center the MECO object, sometimes called a black hole, but we now think it's something else because it's the magnetic fields that create these outer structures, these outer dumbbell structures. And there are also jets in there that stream matter in the form of electrons away from the center. And we believe that these are the structures that nature makes from an intensely strong, powerful magnetic field in a rotating object. In this case, this is a kind of dying star, but if it were a little bit more massive, it would be a dying black hole, star remnant. And I'm now telling you that it's not really a technical black hole. If people want to quibble, they will say it's not a black hole. And I will reply, well, it's a MECO, and if I confuse you in the lecture, I mean from now on in the lecture, by black hole, I mean this black hole with magnetic fields, technically a MECO, and I don't always remember to be so careful. I want to show you a few more examples of this behavior. So here's another object which is doing a similar thing. The exciting object is here at the center. This object. And it is screening out all these radiations, and the dumbbells are now not seen quite so perfectly end on. The accretion disk is now not seen so perfectly arrayed, but the same structures are present. So this is again an object that's spinning around, rotating this way, and the magnetic fields are supporting these elaborate structures that are glowing in the dark. This is a related object, and again, the black hole is here at the center. These are all photographs made with the Hubble Space Telescope. You can find these online. They're public property, brought to you by NASA. This is another object which exhibits another phenomenon that I won't talk about very much because I don't understand it either. We think that it has a series of these shells-like objects, and it might be that the central object is a double star or something like that. But quite honestly, the formation of this object is not understood. And here is a very young object of this kind, And by the way, it's this little fake guy near the center that's exciting all of this glow, and it's a dying star in this case that's doing it. This thing here is just a star in the foreground, has nothing to do with the elaborate structures that you see. And here, the last one is again an object where the black hole or Miko object is here at the center somewhere, but now it's enshrouded in dust, and the big dumbbell structures are on the outside here, not too well seen, and the whole structure is again seen rotating in the sky. So this is the zoo of objects that we find in the sky that seem to exemplify how the physical forces of the universe now bring structure to expanding clouds of gas which are powered by matter first falling in as dead stars and planets and junk in space like asteroids and comets, and then vaporizing it and then pushing the gas out again as very powerful winds, and it's those winds that organize by the magnetic fields into the beautiful pictures that I've been showing you. This is an object which probably is actually two objects which have these outer jets. These outer jets, and the central object here is probably two stars. Now, I want to spend a little bit of time describing some properties of this new type of object. Again, it's not exactly the Hawking black hole, but it's a different variant of it that has magnetic fields. And these magnetic fields are very, very important to the discussion because they create a structure that prevents a complete collapse of the black hole and explains why the black hole is seen to be a structure at a size scale of something less than a light year, and they describe what actually happens when a big blob of gas tries to collapse. This happens at a late stage of evolution of stars. When stars run out of their hydrogen fuel, it's the fuel and burning and the radiation pressure that prevents collapse. Absent that radiation pressure outwards, the object wants to fall together. And the Stephen Hawking picture is that it just collapses until it makes a black hole and can't collapse anymore. We now have a better picture of that based on the fact that they're observed to have magnetic fields. We now understand that something else has happened, that as the object was collapsing, quantum electrodynamics arose and halted the collapse just before the event horizon that Stephen Hawking talks about formed. So the event I'm describing to you has magnetic fields but does not have an event horizon. And it has a very interesting other property, and that is that as this property of quantum electrodynamics is taking place, and I won't write the equations of that at all, I couldn't if I wanted to, the quantum electrodynamics pressure builds up and halts to collapse just at a point when extreme gravitational field effects occur, and then special relativity and general relativity take over, and they do the following thing. They very much change the way clocks work and our perception of time. They create a space where the universe is no longer propagating time the way it does for us here. And so if you send a light ray to the center of this thing, the light ray would not enter this object in the age of the universe. What happens instead is that matter piles on from the outside, onion skin-like, making layers and layers and layers, and in that way it's preserving those phase relationships of nature that describe what Edgar Mitchell called the quantum holograms of the universe. And this is getting pretty abstract, and so I'm going to next describe for you Edgar Mitchell's hologram description of what information is in the universe. And we'll talk a little bit about what holograms are. after I describe to you an important property of a quantum universe. Now, you hear so many people go into the word quantum because it has lots of meanings and comes up in many contexts. But I want to focus now on one particular important aspect of quantum, and that is the fact that it leads to a great deal of uncertainty of how events in the universe will unfold. And I want to do this to illustrate this by a simple experiment that we do all the time in particle accelerators. It's being done now at the Large Hadron Collider at CERN. And we've been doing it since World War II, basically. What we do is we take a particle, say a proton or an electron, and we shoot another particle at it. So we have what's called a proton-photon collision. And when the particles collide, we always find that they recoil, and one goes one way, the other goes another way. That's governed by the laws of motion. But we can never describe exactly what will be the angle at which the two particles recoil. We can tell you in a statistical sense that there's a high probability, maybe 60%, that it will recoil between 40 and 50 degrees. And then a lower probability between around 30 and 60 degrees. But we can never tell you exactly what that recoil angle is. So to be more explicit, let's talk about an individual, non-statistical, but one individual event. So I have a proton, and I shoot at it a secondary proton, and the particle recoils, and I turn on my bubble chamber, and I measure that the recoil angle was 33.42 degrees. Now ask yourself this question. Who or what decided that in this one circumstance, the angle would be 33.42 degrees? And you can take a couple of points of view here. You can say, well, it's random. It's just an accident. Just show me a probability table, and it's entirely accidental. But the universe seems to be more subtle than that. And it's entirely possible that some cosmic intelligence wanted it to be 33.42 degrees. And I'm grabbing cosmic intelligence out of the hat because it's going to come up over and over, and it's becoming troubling to physicists today. And when we talk about this cosmic intelligence, we sometimes hide behind the facade and say, well, we can't talk about cosmic intelligence, how can we ever know about that? And so we talk instead about emergent properties. So I want to clarify what we mean by emergent properties, and you'll see that again when you're reading Scientific American and talking about things in the universe that kind of don't have an explanation. And so the classical example of this is the fact that often you'll see a butterfly in Iowa flapping its wings, and we know that that's disturbing the air around the butterfly. And these disturbances seem to somehow, that we can't describe in detail because they're so complex, because there's more butterflies, and also there's birds, and also there's jet planes, and yet somehow the end of this seems to be that a thunderstorm forms in Siberia 5,000 miles away. And nobody can really tell you exactly how all of the key elements that are in our environment of the Earth actually got together, but something created that thunderstorm. And so we conveniently say the thunderstorm is an emergent property of things that are statistical and complicated and so buried in so much complexity that we can't really describe it in detail with a computer of any size that we have today or could even imagine. So, emergent properties are a kind of a cop-out. We're saying we really don't understand it. But a great deal of quantum phenomena are discussed in the context of emergent properties. So I want to now bravely move forward and talk about Edgar Mitchell's contribution to this, because it was he who first came to understand that these things that we see as modern miracles, where minds are connected together in telepathy, one mind seems to be able to contact another. And how does that work? What physical theory is there for telepathy? Well, Edgar first seized onto something that was first talked about by somebody who's trying to think about what would a quantum computer be. His name was Dr. Schempp in Germany. And Edgar recognized that in that framework of thought was most probably the concept of how minds interact, with sharing of quantum holograms, where quantum holograms express all things that are conceptual in the universe. So my lecturing at you and your thoughts and reactions to it are all spreading out into the universe as wave-like patterns. There are three-dimensional waves, and if I could describe them, they do kind of things like this. Mathematicians would call them quadrupoles, and I would call them quantum holograms, three-dimensional patterns. And Edgar Mitchell points out, and this is the title to the book he was working on, and eventually in this book we come upon this illustration, which shows how this aspect of the brain, it's having this light pattern would be seen as a hologram with this kind of phase pattern. And some structures within the brain having this kind of a pattern would have this representation in a hologram. And if there's a finer structure you may not see, all of it put together comes from this representation as a hologram. And Edgar is quick to point out that if you took this hologram and it were expressed on a piece of photographic film, you could tear the film in half, and the phase relationships would still be in that, in the two remnant pieces. And so, from the two remnant pieces, you could reconstruct the original information, although it would be getting a little blurry. And if you tear it up again, it would get a little bit blurrier still, but the phase relationships are what carry the information. So, to summarize, by quantum hologram, we mean that thing which can carry and describe the information of anything in our universe, and by thing I mean hot, cold, I mean up, I mean monkey reach and grab, I mean anything that the concept that our mind can fathom can be expressed in these quantum holograms. And that the universe is then a flow of quantum holograms, and our brains can tune into them in consciousness, and the black holes are the ones that store the quantum holograms in the universe. And now I'm going to talk a little bit more about the total processing of quantum holograms in the universe. I'm pretending now that you understand everything about quantum holograms. That's what we call that nervous laugh. So here is an attempt to represent the total processing of information in the universe involving the brain, space, and black holes. Now by black holes, again, I mean the Miko variant, which has the more interesting storage properties, being nature's hard drive. At the center, I show, under the word consciousness, the human brain having a left and a right side, the two lobes of the brain, and those are the seat of our human consciousness. And it appears that the left part of the brain, which we've always associated with consciousness and rational thought and ideas coming in of a rational character, and also all the body senses of hearing, smell, sight, taste, touch, those come into the left side of the brain and are processed by the universe by these black hole objects, which we haven't yet penetrated the inside of, but for all we know, make most sense as a repository or the seat of whatever divine purpose or intelligence there is in the universe. And by the way, I am not a religious person. I don't want to spread any religion in this room. I only want to talk about the fact that it's becoming more and more obvious to astronomers and scientists as a whole that there is something like cosmic intelligence. It's getting harder and harder to understand the universe as just an accident. And if we have time at the end, I'll talk about it more, and I will invite you to ask questions about that if that's in your taste. Now, this divine purpose then inside the black hole perhaps has some relationship to what we call the source of the universe, and I am now following the most modern fashion, replacing the G word with cosmic intelligence to sidestep a lot of damage. I don't want to be talking about religion. I want to talk about the properties of the universe that suggest the operation of the Creator guiding its evolution and its development. Now, the right side of the brain has always known that we've always known this to be the seat of our artistic side, our sense of self, our sense of I like and I don't like. And later we will talk about a computer model of exactly what's going on within the brain. But right now I want to express the fact that quantum holograms are apparently now connecting the right lobe to something that we call soul. And by soul I mean what we've always meant in our civilization. There seems to be some part of us that we're born with. And every mother knows that the two children were raised alike, but they're different as night and day. It's kind of like they came into the universe with some baggage or with something that they carry with them that's beyond description, that we can't understand. And we have an experience of it often when we have opinions. I like something. That's processing by the brain, taking reference to the right lobe and what the soul thinks about the something, and it allows us to make judgments of escape, or this is dangerous, or I like, or I'm happy, or bring it on some more. Those are all things that we process in mental work, and I'm going to be explaining soon, after the next slide, again showing how it appears that the left lobe of the brain is resonating with quantum holograms to the black hole objects, which are storing information in general about what's happening in the universe, the physical universe, while the right side is apparently storing and processing information as quantum holograms and through wormholes to the eternal being, which we will call soul. Now, last summer I attended in Prague, Czech Republic. I almost said Czechoslovakia. So that one let in. It's now the Czech Republic and the Slovak Republic. And we, in Prague, had a meeting of mostly physicists discussing issues in quantum mechanics. So this is the world's preeminent quantum mechanics symposium, all academics attending. And we talked about the wave forms of the universe that describe a proton and an electron. And for the first time, I heard in this symposium a discussion of the waveforms that describe consciousness. People are describing it, and you can find it in symposium proceedings under the word helicity, or helical waves, helo waves. The hela is the essential aspect of it, and what we're talking about is having a spiral nature. Remember a coil spring, an automotive coil spring, that kind of helicity. It's my understanding, based on the work of Wilhelm Reich, our predecessor from the 40s and 50s era, who died in federal prison, one of the world's all-time great scientists, that there are important energies in the universe that are described by the same quantum field theory that we've always known to describe particles. In other words, going back to Schrödinger and Heisenberg and Dirac and those guys in the 20s who devised a quantum theory of describing a proton, an electron, and states of the atom and all of that. That same quantum realm supports helical waves of consciousness. And there's a mathematics of this. For those of you who have some mathematical training, that mathematics shows that there's a matrix description of this. Diagonal terms describe matter in the universe. You contain E equals mc squared or things of that kind. The off-diagonal elements of these matrices are the terms that describe helicity, and those describe those quantum wave particles that are spiraling and that are involved in consciousness. I can tell you that Native Americans have known this. My wife and my wife is here with me today in the front row, we attended an elders gathering of the Indian Nation in the Peace Village in Vermont the last couple of years. And at a very high point in the ceremony, the high priestess, Venerable Diwani Yuahu, takes crystals from Arkansas, which she had, very special crystals, and just holding them up in ceremony describes the spiraling waves, upwards and downward spirals, creating a lifelike aspect in these crystals. So Native Americans know of this. Wilhelm Reich, a scientist, tried to describe these. We've known about them, and yet quantum physics is just now starting to describe, encounter, and study them. And that's what's new in quantum physics. So on this slide, I'm writing that the quantum waveforms have a helicity property, and that we've also come to understand from a beautiful issue of a volume of the Journal of Cosmology published last April, May, June 2011, devoted to the study of consciousness. Sir Roger Penrose and Stuart Hamrock, consciousness experts, described in a paper how the brain interacts with the field of quantum holograms, and in particular with the helicity. They discussed microtubular structures within the brain that do this processing. So this is becoming science. And then I mentioned already that the renegade scientist Wilhelm Reich had always stressed that these waves that he called orgone had a helical form. Now, for the next 5 minutes, since we have a few people who are interested in mathematics, and since university types will not listen to anything that has to do with consciousness, telepathy, and so on, if it's not mathematical, I want to just go into a short 5-minute mathematical digression. Some of you can go to the beach, just don't worry about it, and I'll wake you up in 5 minutes. Okay? The way that this apparently works is that the 4 spatial dimensions that we've always known are actually not simple numbers, they're actually imaginary numbers. They have a real and imaginary component to them. And by the way, this is a theory which is a kind of a variant of string theory. It's what might be described as a very mild form of string theory. It's saying that we don't live in a universe of of 8 or 12 dimensions, but rather we live in what Einstein always described as a 4-dimensional universe, 3 dimensions of space, and a 4th dimension of time. And now we're seeing that those 4 dimensions have a frequency aspect associated with them, and that's the aspect that quantum physics discussed in the 1920s era. Schrödinger, Dirac, Heisenberg, that crowd. And we're saying that that same medium, the phase relationships medium of 4-dimensional space that describes particles, also describes consciousness with Edgar Mitchell's quantum hologram. Now, in such a space, mathematicians have been describing that. Line 2 says the universe is mathematically called a Stein manifold. That would be then a 4-dimensional structure of complex number of dimensions. And it's then Parsifal's theorem, also known to mathematics, that describes how the relationship of the imaginary component to the real component, and we won't talk anything more about that. Then it's very critically important to this that the brain is now understood and realized and seen to be able to form the complex conjugates by making mirror symmetrical images, and I'll describe this in the last part of the talk when we really get into the nature of what is consciousness. But we're doing mathematics right now. And that in mathematics, the cross-correlation of a quantum hologram with its complex conjugate within the brain then expresses the realization of that information and the currents that are then the mirror neuron networks and the currents that we see operating the brain, and then become the conscious activity that can be measured with functional magnetic resonance imaging. So those patterns are made here on line 5. And for those of you who want to come to terms with the quantum relativistic theory of gravity that also explains consciousness, the theory that eluded Einstein because it didn't occur to him to include consciousness in the quantum field theory. That theory is now explained by the Lorentz transformation, enforcing these relativistic Einsteinian aspects and the strong principle of equivalence. Well, that's a lot of big talk and big words, so all of you can just come back from the beach now. We're done talking about mathematics. I'd like then to say something that's much more simple, and that is, what is the actual logical function of the brain in the act of consciousness? And all of you are invited when you go home to think a little bit about what is happening when you're having thoughts, when you're getting ideas, and when you're waking from a dream that you can't understand. It's my understanding that what's happening is that the brain is working in a way that's importantly like a computer. And I know something about computers because I'm old enough to go back along the full history of them. And I actually built a computer when I was a young postdoc at Caltech in the 60s era. You couldn't buy a computer you could buy a desktop or a laptop computer back in those days. You went and bought a great big mainframe computer, and you bought an air conditioner too. The computer has at its very core what's called a computer clock. And the function of the clock is just to build in a regular beat pattern. Compute, 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 compute. And it does something actually very much like our heart. Our heart says squeeze, 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 and transfer blood. But it does things to the electrical system too at the same time, and that's what we're going to focus on now. Because from our heartbeat, the brain gets a signal and develops that into the computer clock. So what happens in a computer clock beat is this next subject, and that I learned from building a computer And what happens is the computer variant, now look at the left side of my screen. And the left side of the screen is what I believe is happening in a digital computer, like the one right here. And the right side is what I think is going on in the brain, and I'll get to that in a minute. In the digital computer, then, on the left side, in a single compute cycle, an input number is ingested by the central processing unit, and a second number is ingested, and the two are brought to the central processor, and a logical step is taken by the central processor. The processor, by its instruction set, is told add the two numbers, or is A bigger than B? So, in one computer beat, the two numbers are introduced, a logical operation is done on them, and the logical output comes out to an output register, which then holds the sum of the two numbers, if that was the instruction, or an expression of the logical A is bigger than B, or whatever the instruction set commanded. That's what's going on in your digital computer again and again and again. And this little box here does it 3 billion times per second. We can only do it 16 times per second. So that's got to speed. But nonetheless, it's doing the same thing logically that we do, except when the brain does it, it is taking from the left side of the brain a sensory perception of some kind, like a pinch feeling in my hand, or I hear somebody shuffling their feet back there, or I see that the screen isn't as bright as I hoped it would be. So a sensory piece of information. And then my soul is resonating with the right side of my brain, and it's making opinions of everything. The opinions might be, I like this, or this is scary, this is creepy, let's get out of here, or it might be, well, that's lovely. So, these are the two inputs equivalent to the input register on the left side of the screen. And so, sensory perception comes down to the central processing unit, which has the clock beat, compute, compute, compute. And it's what causes you have to have the feeling about the sensory information based on your soul. In other words, this is machinery by which the brain is taking two bits of information, comparing them, and allowing it to have an opinion which might go back to the soul, or which might now go to the nervous system and say, scram, let's get out of here, this is dangerous. Or creep me out, or duck and cover, or whatever. Or bring it on, this is terrific. So, that, I believe, is what's going on in your brain. The two halves are bringing information together. A clock function is providing a beat at 16 cycles per second that's allowing you to compare the information, have an opinion about it, and take an action which might be to the motor neurons, causing you to walk away, or duck and cover, or enjoy and smile. That is the brain process of consciousness. The mathematical treatment of that I gave you when some of you were at the beach is the superposition in the brain of these quantum holograms with their complex conjugates formed within the brain, which then produce the currents in the brain that are seen in functional magnetic resonance imaging. And that's where I want to go next, because Edgar and I speculated about these things for the last 10 years, and guess what? All of a sudden, the brain research community is discussing it, discovering it, and not really even understanding, in my view, what they've got. I'm at Harvard University. I've talked to people in the brain research community and have described this to them and asked them, is anybody at your laboratory talking this way? And the answer is no. The person I talked to is a scholar from Taiwan. I asked him also, is anybody in Taiwan talking this way? And the answer was no. So you know more than the brain research community at Harvard. This is what the brain research community is giving us. And before I discuss this slide, I want to describe to you a piece of research which is crucial to this, that was discovered beginning the era 1998, 1999, and 2000, being discussed first in Italy, where it was discovered by a Dr. Visaliti at Parma University in Italy, and then discussed in university in Europe, and now in America. And it's a network of neurons in the brain which appear to be the seats of consciousness and our human awareness. And I'm now talking about that sense of I'm aware of myself. I can even say I'm aware I'm aware. And this has puzzled science for these many years. What is that? What is it that gives me my self-identification and this sense of personal self-awareness? It's seen now in a network of neurons that pervade the entire brain and are all interconnected, and they're called mirror neurons, spelled just the way you imagine, mirror neurons. This body of neurons was discovered when researchers there, researching monkeys, were doing a very simple experiment. They put a monkey in a quiet space and with no distracting backgrounds, put a roll of peanuts up there for the monkey to see, and the monkey immediately reached for the peanut. That was recognized as a certain brain pattern in the wave, in the brain, and that wasn't considered to be too surprising, except when they looked at another monkey who was watching a monkey in a movie reach and grab a peanut. They noticed that the observing monkey had the same brain wave pattern. In other words, it's the reach and grab that's inducing a conceptual pattern or brain wave in the brain, and in the monkey that's doing it, it's also triggering mirror neurons, but the monkey observing that behavior of reach and grab also has that brain wave pattern. That's getting close to Edgar Mitchell's quantum hologram. So, it's now accepted that there are patterns in the brain called motor neurons that describe the emotional context of our lives, the things not only monkey reach and grab, but red and up and cold, all the things that are conceptually available to our consciousness are expressible in brainwave patterns in the mirror neuron system. So, I want to show you how these mirror neurons are actually seen in brain activity. And I'm showing you here from a paper by a more recent effort by a research team. This is a paper written by Pizzola, published 3 years ago, and it's made quite a stir because these are now the functional magnetic resonance imaging patterns seen in 3 human individuals, and they show different sections of the brain when various emotional concepts are being shown to the eyes of the subject. So here are various sections of the brain. This is the brain. These are sections of the brain, the topmost on down to the lowermost, and then you have the spinal column below. These sections are now the various panels. So this is subject 1, 2, 3. This is subject 1, subject 2, and human 3. And these are then the various levels from, let's see, this is the top of the brain here. So this is the upper section, the small one. And then the next and the next and so on. So for the 3 human individuals, these are the sections of the brains of 3 human beings, all experiencing the same emotion. And I hope that you can see that they tend to be the same. So that, let's look, for example, I don't know, at this one, this section of the brain, so that's one of the sections down here. So this section in this human has approximately the same activity pattern as this section, the same section in this human, and approximately the same in this section by this human, except here they're a little bit more intensely expressed, so he's had a little more fun. To underscore this a little bit and help you see this, I've shown you now just one of the sections in the 3 humans. So this is, I think, the section just below center, this section of the brain. And to show you that these brain patterns in 3 human individuals having the same emotional experience, to just make the point that human emotion is expressed in these brainwave patterns. And this is a little resonant pattern here, seen of electrical activity, seen here, and again seen here. Then you have these 2 more subsidiary patterns. The Rocky guy does it best, but you see they're approximately here, not perfectly shown, but again approximately here. And if you look at more structures, this here at the bottom, again here at the bottom. And then they can't be 100% ideal, because these subjects are, after all, one has an itch on his nose, and another one is remembering that, we forgot to call his mother before he got in subway, and whatever. So we're not in total isolation. The brain can't be totally identical from one subject to another, but you can get the idea that they're pretty close here. And they seem to be telling us that the brain responds to an emotional context with brain patterns which are apparently the same in all human beings. I'm not aware if this has been done in some way to see if the same patterns emerge in monkeys or in birds. For example, humans and monkeys and birds all have fear. We all express many emotions in much the same way. Why shouldn't we all have the same brainwave patterns? And wouldn't that then explain why some very sensitive people can actually tune into the feelings of an eagle? Or we can perhaps have telepathic exchanges with a monkey expressing joy, pleasure, or want for food might very well have the same brainwave patterns as humans, and I'm not aware that this experiment has been done across species. And if anybody in the room wants to correct me, I'd be interested to hear it. Now, I forgot to tell you something. A minute ago, you saw me in a pregnant pause because I did remember I wanted to tell you something, but I didn't remember what I wanted to tell you, and that is that the mirror neuron system that was first discovered, I told you, in Italy, discovered as now revealing that monkey reach and grab is a neural pattern that you get whether you're actually reaching and grabbing or watching somebody reach and grab. That mirror neuron pattern has also been found and researched and discovered to be related to our sense of self-identity and our consciousness. And we know this because the mirror neuron pattern is very weak in autistic children. People in which that mirror neuron system is weak or absent cannot easily distinguish themselves as me as separate from you. They can talk about some things in our universe and describe maybe colors, and they can function as individuals and maybe put a shirt on, but they don't have a sense of I'm me and you're you and I see you and you're sitting in a chair and I'm standing. They can't do this simple conscious self-awareness as well as a normal functioning human being. And I'm bringing this up now because it's part of my story. This pattern of mirror neurons and these brain waves of consciousness are actual consciousness activity. They're the things that allow us to say, I'm afraid of, I like, bring it on, I can't wait for tomorrow because I'm having a birthday party. We can have long trains of thought by adding and piling on these mirror neuron structures, and that is an explanation of consciousness. And now I've already begun to allude to the fact that it apparently is something that humans, and perhaps humans and animals, can share. And isn't that what telepathy is? And it'll be amusing to you that if you read the literature of scholars, you won't hear the word telepathy, they'll talk about empathy. That's safer. That's supposed to be safer. So we can talk about empathy. But don't tell me about telepathy, and don't tell me about remote viewing, and don't tell me about channeling, and don't tell me about the CIA experiments looking into Osama bin Laden's cave and any of that stuff. Send all that stuff off to the National Plan. So you see where I'm headed now. I'm telling you that with this understanding of a universe dominated by quantum holograms of information, processed by the human brain, stored and processed and perhaps added to by a creative intelligence at black holes, we have a picture of what consciousness is that now allows us to talk about, remember slide 2, the Modern Miracles? Telepathy,
Crop
circles, remote viewing. Should I go back to that, or do you remember them? UFOs, maybe? UFOs are a very interesting case of this. The science community is dreadfully afraid of UFOs because we all know that's impossible. But unfortunately, a great many people see them and describe them, and the science community just can't escape this anymore. And I can understand it in the formalism I just described to you. So if you won't report on me back to some people at Harvard University, I'll tell you what's probably going on. The UFO evidently has the ability to scan the contents of itself and its occupants, the people inside, and create a quantum picture of self and contents, and transmit that picture to our space-time continuum and appear anywhere and any time they want. By projecting that information, which is what the craft does by that hole in the bottom, you know, the bright hole in the bottom, that's projection of the energy out into the universe, and that gets directed to our space-time continuum, and the UFO appears and does its stuff. If you were to see this happening before you, I've talked to people who say they have. Let's say the UFO is going to appear in that corner of the room. Its appearance would take place in about 4 seconds. In the first second, you would simply notice there's some kind of fuss up there in the room, but you wouldn't know what it was. Just a telepathic sense of fuss. In the second second, you would notice, there's something that's colorless and transparent, but you kind of make out a form. It's ghost-like. In the third second, it would take on color, be no longer transparent, and you would see the form more firmly resolved, And then in the final second, it would achieve its mass. It would have presence and whatever conscious activity are associated with the occupants of the UFO. That's what it would look like for information to propagate through the universe to this corner of the room and re-manifest the spacecraft before our eyes. So I hope that you will now take some pleasure in the fact that there is emerging an idea about how information propagates in the universe and enables all of those things that science had a hard time dealing with. Fairies in the garden. What was St. Paul's burning bush? Orbs. People see orbs. All of this kind of stuff that we've said, divide and conquer, send off to the National Enquirer, it doesn't exist, it can't be investigated scientifically, has some kind of an explanation. And so in the last couple of slides, how am I doing on time, Lou?
Yeah, just wrap it up the way you're going, we'll be fine.
This is intended to be a wrap-up and say what I think I've told you about a new picture of what the universe is that involves consciousness and our sense of I'm aware and that I can even communicate across space and time. The two halves of the brain can receive and duplicate and transmit these quantum holograms, much according to the description of Edgar Mitchell. These, the waves themselves are now being dealt with in the physics community in their helical form, long after they were first described by Wilhelm Reich, and you will see in his writings a kind of a spiral form that he draws in every now and then. They are stored and processed at the surface of these black hole-like MECO objects, and I didn't tell you all that we might, and if you want to know more about black holes, ask me. They penetrate space and propagate at faster than the speed of light, and they propagate faster than the speed of light because, after all, the Einstein general theory of relativity and the special theory say that you cannot propagate a particle faster than the speed of light. But these are not particles, these are waves, and they are properties of space itself. And these propagate instantaneously through the universe. So when I said that these are apparently a form of string theory that's more like imaginary or complex numbers, and that space itself is a complex Stein manifold, that means that it's instantaneous propagation, and Star Trek got it right. Everything you saw in Star Trek is true. They called it subspace. Remember, warp 1, warp 2, warp 7, warp 9. That's subspace. And that's what I'm now talking about, superluminal propagation of quantum holograms. And then I just made the point that this is the process that enables all of the modern neurons. So this dark energy is faster than the speed of light, and this is actually been shown experimentally, and I didn't make that point. The black hole, a MECO object, holds information at a high redshift for all time, and so the universe does not lose any information ever. Dr. Edgar Mitchell gets our applause in a few minutes because he is the one who figured this all out. And that our sentience results from the brain resonance requiring a heart rhythm that then is the basis for the 60 Hz beta frequency brain rhythm. And these gravity and quantum effects are controlled through the dark energy, and I believe this is a last slide that says sentient beings are apparently also quantum. And by the way, these are more speculative now. But I think that we can now understand also then that sentient beings are the missing Higgs particles and that the CERN collider will never discover them, and that there's a lab of mathematics as particle solution of the Einstein international field equation. I can't wait to discuss them with you. The universe seems to be built and to evolve and magnify its creator, and that's for a longer discussion of a different kind. So thank you all very much.
I have a question, if that's all right.
We would like to have a few questions, and do you want to keep a lid on this in some way, Lou?
Yeah, let's see.
Is there an organizational
Half an hour of questions? And if you must go, obviously you must go. And I have the first question, if I may, sir.
And if I just find out, you won't be considered interrupted if any of you want to leave at any point. And so I'm here to answer questions now in front of all of you and informally later on. So fire away.